Hey everybody, here's your 5-9 Math Excel video, and so this is where we start talking about imaginary numbers. Imaginary numbers. So the graph of something like that or like that. We're not really going to get into graphs, but these are the ones with no real solution. Okay, so to start with, 591, this is number 1, it says express it in terms of I. So a most important formula is I squared equal -1, and then if you go backwards and take the square root, I would be the square root of -1. So let's just think about that for a second. So if you have like the square root of -144, you can say that's square root of -1 times the square root of positive 144. Or you can write it with this part in front, which is what we're going to do. We're going to have square root of 144 times square root of -1. And so then it's just 12i. So you'll get the hang of these. You know, if you do square root of -36, that would be 6i. Square root of -16 would be 4i. And so forth. So that's the basic idea. So now for your next one, you're doing the square root of -6, and so you're doing square root of 6 times square root of -1, and that can't be broken down, and so your answer is going to be I square root of 6, because we like to put the I in front of the square root sign. So again, over here I'm showing you the breakdown of 6 times, or the breakdown of 6 would be 2 times 3, which is not a perfect square, like 4 from 2 squared. 3 squared is 9, 4 squared is 16. There's no breaking it down. And so the square root of 6 was already simplified as much as you could. And again, the reason why we don't do it this way is because you might think the square root sign goes like that, where the I is underneath it. So we don't want that. We want to put I in front of the square root. Okay. For our next one, we have the square root of -245, and so that's the square root of 245 times square root of -1. So on this one, it ends with a 5, and so I'm saying 5 times something, and it was 49. Now 49 breaks down into 7 times 7. So if you have a pair of them, I circle it, and then I put the 7 in front, and then I put my leftover here. So that's 7 square root of 5. So that means your answer is 7i square root of 5. Again, if you really needed to, you could have said 245 divided by x and then looked in your table, and you know that's where it would have been 5 times 49. Okay, on your next one, it says plot the complex number 5i and its absolute value. So the first thing is, if you have an ordered pair a comma b, it could be written as a plus bi, and so in this case it's 0 plus 5i, and so that's 0 comma 5. Now when you think about graphing it, normally you would think of the x-axis and the y-axis, but in this case we're thinking about the real axis. So the real axis is the x-axis, and the imaginary axis is the y-axis. So this is 0, 5. So that's the graph of it. The next step is to do the absolute value of 0 plus 5i. And so you take the long square root of 0 squared plus 5 squared. So you just take your coefficient. It's kind of like using the 0, 5 here, and you're doing 0 squared and 5 squared. And so that's the square root of 25, which is just 5. So that means the absolute value of 5i is 5. On our next one, we want to plot the complex number and find its absolute value. This one has -2 plus 2i, and so based on what we just did, this would be the ordered pair -2, 2, which would go left 2 and then up 2. So on your real axis, it's -2, and on your imaginary axis, it's +2. And this is one where there's a multiple choice graph. So you pick the graph that goes through that point. So it's really, the graph is just a dot. That's all it is. And then you're going to take those numbers and you say square root of -2 squared plus 2 squared. So that's the square root of 4 plus 4, so square root of 8. And you can break 8 down into 4 times 2. There's your pair of 2's, and so you have 2 square root of 2. So that 2 is your leftover. That's your pair of 2's. So if you have a pair of something, you put it in front, and your leftover goes here. So you have 2 square root of 2. On the next one, it says write the expression in the standard form a plus bi. So you have parentheses 2 minus 4i plus parentheses 7 plus 8i. If it's plus, you can just drop it, and then I just arranged it where you put 2 plus 7 next to each other and -4i plus 8i close together. So that's just associating them different. So then 2 plus 7 is 9, and -4i plus 8i is plus 4i. So then that's your answer. So if it's a plus sign, you're able to just drop it. On your next one, you have parentheses in front, but then you have a minus sign in between. So you can drop it in front, but then you got to distribute the negative for this one. So you get -6 minus 9i. And then you just want to group them, 5 minus 6 and 4i minus 9i. So you get -1 minus 5i. On the next one, you want to multiply. So you have 7 plus 8i times 10 minus 9i. And you're just doing FOIL, which is first times first, outside times outside, inside times inside, and last times last. So the only difference is you still have I terms. And so for your FOIL, first times first would be 7 times 10, which is 70. Outside times outside would be 7 times -9i, which is -63i. Inside, when you multiply those, is 8i times 10 is 80i. And last times last would be 8i times -9i. Now that gives you -72i squared. So earlier we said I squared is -1. And so if you want to think of it this way, you have -72i squared, which means -72 times -1 from substitution. And then you're just going to change it to +72 because a negative times a negative is a positive. So that's the real mathematical steps. Now, now that you understand that, you basically just say, well, if it's -72i squared, we're going to cancel that out or cross it out and put plus 72. I mean, that's how easy it is. If you see something with I squared, just change the sign and then put the number. So then you just need to do 70 plus 72 is 142. -63i plus 80i is 17i. So just treat it like terms, just like it were for x. On your next one, we have 5 plus 4i quantity squared. So just like you had before, if it were 5 plus 4x squared, you would do 5 squared is 25 plus 2 times 20x because you got to have 20x and another 20x is going to be 40x, and then plus 16x squared. So that's what it would have been if you have x. Now in your case you have I instead. So you're going to have 5 squared is 25. Then you're going to say 2 times 20i, which is 40i. And then you're going to have plus 16i squared. So if you have 16i squared, we just cross it out and change it to negative 16. And then 25 minus 16 is 9, so you get 9 plus 40i. Okay, on the next one, it says perform the indicated operation.
Do you mind helping with my homework?
Sure, just... Okay, I'm back. So on this one, what we're doing is we're starting with 13 minus 3i over 7i. What you have to do is use the conjugate of the denominator. It says eliminate the complex number in the denominator, multiply the numerator and denominator by the conjugate of the denominator will now be a real number. Okay, so all that means is the conjugate just means change the sign. So if you start with 7i, then you're going to put negative 7i on bottom and also negative 7i on top. Because if you think of, what is negative 7i over negative 7i? That's like positive 1, and you can always multiply by positive 1. So you basically just need to have the same thing on top and bottom. So now from there we want to distribute. 13 times negative 7i is negative 91i, and negative 3i times negative 7i is positive 21i squared. Then we change that to negative 21. And then down here we go 7i times negative 7i is negative 49i squared. So again, we just change that to positive 49. Now my next step was I rewrite it and put the I term last. And so you have negative 21 minus 91i over 49. And then just split them up. And so you get negative 3/7 minus 13/7 I. Now that would be my preferred answer. But you might see the negative sign out to the side, not on top, but to the side. And if you do that, you need a 3 plus 13i over 7. So notice this says minus 13/7. And if you have a minus sign here, you're like saying negative 1 times this and negative 1 times that. And so that's how they're equivalent. So to the side would indicate you distribute to the numerator, not to the denominator. So I don't like putting the negative sign to the bottom, but sometimes you may see it that way. I prefer this way. Okay, so our next one we have divide and simplify to the form a plus bi. So in this case we want to multiply by 1 using our conjugate, and so if you have 1 plus I has conjugate 1 minus I. So all you do is change the sign of the I term. So you keep your sign of the constant and change the sign of the I term. So we want to multiply by 1 in the form 1 minus I over 1 minus I. So what we do is 28i times 1 is 28i. 28i times negative I is negative 28i squared, so you can change it to plus 28. And then 1 times 1 is 1. Your outside and inside terms would cancel. That's the whole point of multiplying by the conjugate. And you would have I times negative 1, which is negative I squared. which is really just plus 1. So then you just rearrange it where the plus 28 goes in front, the 28i goes in back, and 1 plus 1 is 2. So then you just divide it, and so you get 14 plus 14i. So basically, like I was saying here, I squared is negative 1, so negative I squared would be positive 1. And so that's why we're doing a plus 1. So it all works out where 1 plus 1 is 2, and then you just simplify. On your next one, you have 13 minus 2i over 3 plus 5i. So if you have a plus, then just make it minus. Again, don't change your sign of your front term, just your I term. So then you do 13 times 3, that's your F for FOIL. 13 times negative 5i, that's your outside term. Negative 2i times 3 is your inside term. And negative 2i times negative 5i is your last term. So you have 39 minus 65i minus 6i plus 10i squared. And again, if you have plus 10i squared, we just cross it and make it negative 10. So then 39 minus 10 is 29, and negative 65 minus 6 is negative 71. Then for your denominator, we cross this out and say plus 25, so 9 plus 25 is 34. So then you're very close. You just need to split them individually, and there's nothing that reduces. And so we just have 29 34ths minus 71 34ths I, because they want it of the form a plus bi, or in this case a minus bi. It just depends on whether you say whatever the sign is, plus a negative. Okay, on our next one, we have 13 over 5 minus 7i. So then we just say 5 plus 7i on top and bottom. Then you want to do 13 times 5 is 65. 13 times 7i is 91i. And then 5 times 5 is 25. Your outside and inside terms are going to cancel because you have minus and plus of the same thing. And this is 49i squared. So that really changes to plus 49. So this is 65 plus 91i all over 74. And so then you just split it. So that's how you do it. Now on this one, what's different is you have your 7x squared plus 175. So you want to try to factor out something. I would say obviously try a 7 because that's what's in front of it. And if you do 175 divided by 7, you get 25, which works out perfect. Then you're going to divide by 7, so it goes away. Well, we're just kind of working with this side. I'm just going to say aside. So if we have x squared plus 25 equals 0, like we did on the first problem, we would say x squared is negative 25, and so that's really 5i. And then we keep the 7 in front, and you're just going to have to say x minus 5i and x plus 5i. So basically the reason is because when you're taking your square root, you need a positive and negative. And so if you have 5i as a term, then it's like x minus 5i. And, you know, for the other one, x plus. Just like if you had 3, then you really think of it x minus 3. So that means right 3. Anyway. That's the way it works. So you need x minus and x plus of the same number. Now on your next one, you want to use the quadratic formula, so they're kind of like circling around to something you've done before, except for there's one little weird thing. Okay, here we have 3x squared minus 7x plus 10 equals 0. Your quadratic formula is negative b plus or minus the long square root b squared minus 4ac all over 2a. So negative b, so minus a negative 7 is a positive 7, plus or minus. Okay, that squared is 49, and then minus 4 from the formula times a, which is 3, times c, which is 10. Now, this is the part I would type in the calculator. You basically do 49 minus 4 times 3 times 10. And that gives you negative 71. So this is where your discriminant is negative. So on the other lesson, we said that's no real solution. But on here, we're going to say there's two imaginary solutions. So what you basically do is like make the square root of negative 71 as I squared of 71, because you can't break that down anymore. And so then you basically split them up. You know, your plus and minus means you have two answers. So you have 7 minus I squared of 71 all over 6. And 7 plus I squared is 71 all over 6. Okay, on your next one you have I plus the square root of negative 4, all of that minus the quantity 7 plus square root of negative 16. So my first step was simplify. If you have square root of negative 4, that's really 2i. And if you have the square root of negative 16, that's really 4i. So I just did that substitution right there. Or work it out. Now from there you want to drop your parentheses in front, but then distribute the negative 1. So you have negative 7 and minus 4i. And from there it's easy, you just combine your like terms. 1 minus 7 is negative 6, 2i minus 4i is negative 2i. So that's your answer. So remember, if you have a minus sign with parentheses, you distribute. On this one, you have a plus, and so you just drop it. So you're basically changing square root of negative 4 to be 2i, change the square root of negative 36 to be 6i, and then just drop it. So 8 minus 3 is 5, 2i plus 6i is 8i. So 5 plus 8i. They always want the number plus the I term. Okay, then for the next one, it wants you to multiply, and you have 10i times 4 minus 3i. And so you just distribute, so you get 40i minus 30i squared. Then you just cross it out and say plus 30. So 40i plus 30 is the same as 30 plus 40i, because that's your a plus bi. Okay, on your next one, it gives you this paragraph. The multiplicative inverse of a complex number z is 1 over z, and that's where it's not 0. So you actually can do the division. It's not a divide by 0. And it wants you to find the multiplicative inverse of 1 minus 6i. So the first step is just put 1 over that expression. The next step is just do it like you did a moment ago, like change your minus 6i to be plus 6i. And you need to do this on the top and the bottom. So you're basically multiplying by your conjugate. On top and bottom, in the numerator and the denominator. Because if all you did is multiply in the denominator, then you wouldn't be multiplying by 1. So that's why it has to be the same thing on top and bottom. So then you're just doing 1 times everything, so that's just 1 plus 6i. And then 1 times 1 is 1. Your outside 6i and inside negative 6i cancel. And then you have negative 6i times 6i is negative 36i squared. So again, when you're doing FOIL, your middle term cancels when you have negative and positive. So then if you have a negative 36i squared, we just cross it out and say plus 36. So if you see a negative something squared, you make it a plus. And then that just simplifies to 1 plus 6i over 37. And then you just make it split. So 1/37 plus 6/37 I. So just a quick word of caution. If it were 37 over 1 plus 6i, that's not the same thing as 37 over 1 plus 37 over 6i. You can only split it if you have a compound numerator. Can only split it if you have a compound numerator and not a compound denominator. So in other words, this was fine to split, but this is not. Okay, then for our next one, we have extra practice A. So you have x squared plus 196 equals 0. Just move your 196 over, and then take your positive and negative square root. So that's plus and minus square root of 196 times square root of negative 1, and that's going to be 14. So basically, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, you just reverse them, and 15 squared is 225. So again, it's going to be faster for you if you memorize these. Otherwise, use f1 equal x squared and just go through your list and look for 196 and then find the square root. So for example, well, we had 196. We can just say square root of 196. Or like we said in that other video, 196 to the half power is also 14. So again, try not to rely on your calculator too much for stuff like this, because on your SAT, part of it may not let you use a calculator. You're going to have to do something like that. Okay, so for your last one, you have 4 minus 3i over 3 plus 2i. So you basically take your denominator, put it twice, and flip the sign of the I term, and then distribute. 4 times 3 is 12. 4 times negative 2i is negative 8i. Negative 3i times 3 is negative 9i. And negative 3i times negative 2i is positive 6i squared. So you cancel it and you say negative 6. And then in your denominator, 3 times 3 is 9. Your inside term and outside term cancel, and then you get 2i times negative 2i is negative 4i squared. So that one you cross out and say plus 4. So then you combine all your terms. You never want to leave I squared in your answer. Always substitute I squared equal negative 1 and simplify. So basically, 12 minus 6 is 6. Negative 8 minus 9 is negative 17, so we get negative 17i. And then 9 plus 4 is 13. So then you just have 6 thirteenths minus 17 thirteenths I. Alright, so that's going to do it for that video. Hope that helps.